Good morning, students. See, in last class, we are discussing about aldehydes, ketones, and carboxylic acid. We shall continue our discussion on again aldehydes, ketones, and carboxylic acid. So, we are discussing about nucleophilic addition reactions of aldehydes and ketones. Then we studied how hydrogen cyanide HCN, a Cn minus a nucleophile attacks on carbonyl group to form cyanohydrin. Like that, sodium bisulfide, it can also react with carbonyl group to form an addition product, and it forms a sodium bisulfide product. And we discussed about the addition of alcohol to an aldehyde to form an acetal. We shall study it. Say, nucleophilic addition reactions of nucleophilic like Cn minus, then NaHSO3, which we studied. And now, say this is an R C double bond OH, so which is an aldehyde. So this aldehyde, when it reacts with a molecule of an alcohol ROH in the presence of dry HCl. See, addition product takes place here, nucleophilic. That means it's substituted. So we can say R, C, and one of the molecule which is nothing but here H, and here it is OR, and this will become, see, SO minus. Again, in presence of another molecule, it is a reversible reaction. One molecule of alcohol. So this is an alcohol. So this alcohol adds here, and you will get an addition product. Again, when it reacts with another molecule of an alcohol, so we will get an acetal or COR dash, and this is nothing but dash, and here also OR dash, and this is called acetal. And acetal is formed. Are you clear? And acetal is formed. So successively, two molecules of alcohol adds on the carbonyl group, and we will find the acetal. And we shall study the reaction with ethyl glycol. We shall study the reaction with ethyl glycol. See, we have ethyl glycol, CH2OH, and again CH2OH. So when it reacts with a ketone, R C double bond O R dash, a ketone. So it is ethylene glycol. A very simple reaction. This is an addition reaction. Ethylene glycol, CH2OH, ketone, R, see, it's a ketone, R C double bond O R dash, ketone. When it reacts with ethylene glycol, it is a reversible reaction in the presence of dry HCl. Say, ethylene glycol reacts with a ketone. We will get, see, R, again C, and this R dash we have here, and here it is OCH2 and OCH2 group. So this is called, see, a ketol. A ketol is formed here. A ketone is formed. An intermediate product, so it is nothing but an, say, nucleophilic addition reaction. Which substitutes here. Are you clear? Ketone is formed. See, in presence of an alcohol, acetone is formed. A very simple reaction. That's all. So, ethyl glycol. What is the reaction condition? Reaction condition is triaxial, which is a reversible one, which favors the product formation. In ketones, we have bulkier 2-methyl group, and we will get the product. Are you clear? So, by the removal of water molecule. So, here dehydration takes place. So, again we have to study the addition of ammonia. Are you clear? So, we studied the nucleophilic reaction. In nucleophilic, hydrogen cyanide addition, sodium hydrogen bisulfite, and reaction with aldehyde and alcohol to form an acetone. To form an acetone. Another one is reaction with ketone with ethylene glycol. With ethylene glycol, where ketone is formed. What is the reaction condition? Again, it is a reversible reaction, triaxial, and it favors the product formation. Are you clear? See, repeatedly, very slowly, you have to practice the reaction and you have to understand the concept. What is there? Okay, we shall continue our study on next. See, addition of ammonia to carbonyl, addition of ammonia NH3 and its derivative to carbonyl. Are you clear? See, in this addition, a general what we have to study. See, a carbonyl group, C double bond O, which is nothing but a ketone or an aldehyde. So when ammonia derivatives, see NH3, H2N, and Z is a derivative. It may be anything. NH2, NH3, it may be hydrazine, hydroxylammonia, 2,4-DNP. Okay, here, see, in presence of HCl, a rapid dehydration takes place. See, H2O is removed here. H2O is removed. And it forms carbon to nitrogen bond. So no doubt it forms an intermediate. What is that intermediate? We shall study. Say here C to double bond N, that is a derivative, is formed. This is very important. By removal of water molecule, rapid dehydration takes place. See, in acidic medium. See, it is a carbonyl group. When this carbonyl group reacts with an ammonia or derivative of ammonia, and we will get, by the removal of water molecule, C to N bond is formed. That is important. Are you clear? See, an intermediate is also formed. What is that intermediate? C to double bond O. Again, when it reacts with, say, which is a reversible reaction, in the presence of NH2 and Z, which is a derivative of ammonia. So we can find, see, R, H, then again here, we can find, so this is an intermediate where OH and again N, say H, Z. Are you clear? So it is an intermediate. In next step, in presence of mineral acid like HCl on acidification. So removal of water molecule takes place, and C to N bond is formed. C to N bond is formed. Which bond is formed? C to N bond is formed, and plus H2O. So any derivative it attaches to this. So this is the skeleton of the equation we have to remember. Are you clear? See, very important, many reactions are there. We have to concentrate. When carbonyl group of aldehyde and ketone reacts with ammonia and its derivative, it forms an intermediate. This intermediate, on reacting with a mineral acid, due to rapid dehydration, removal of water molecule, we will get carbon to nitrogen bond. Carbon to nitrogen, a very important reaction. So we concentrate, and this hydrochloric acid and carbon to nitrogen double bonds. So we shall study many reactions. So this is the basic thing which you have to remember. We shall study many reactions. See, particularly an aldehyde CH3 C double bond OH. So which is acetaldehyde. So when it reacts with hydrazine, see H2N and NH2. So which is called hydrazine. So which is a reversible reaction in the presence of HCl, and removal of water molecule takes place. We can find here. So we will get hydrazone. See, acetyl hydrazone CH3 CH, then double bond N and NH2. So this is acetyl hydrazone, which is formed here hydrazone. And this carbon to nitrogen bonds. Are you clear? So very simple reaction where removal of carbonyl group C2O bond and formation of C2N bond takes place. And this is nothing but a hydrazone. Well, see hydroxylamine NH2 OH. So oxime is formed. C double bond O H. When it reacts with hydroxylamine, so we will find this is a reversible reaction. Again, the removal of water molecule minus water molecule. So we will get CH3 C double bond N OH. So this is H. And oxime is formed. Are you clear? See, very simple reaction. CH3, C double bond N, H and OH. Are you clear? So this is nothing but oxime, and that is hydrazone. CH3, C double bond N, NH2, H. Are you clear? See again, when it reacts with 2,4-DNP. Say, we shall study reaction with 2,4-DNP. Dinitrophenol hydrazine. See, hydrazine, you know, H2, NH. When it attaches to a phenyl, a benzene ring. See, this is one. 2 NO2 group, 4. See, this is called 2,4-dinitrophenyl hydrazine. 2,4-dinitrophenyl hydrazine. See, very specific reactions of aldehydes and ketones, where other organic compounds like carboxylic acid and alcohol does not respond this reaction. Only aldehyde ketones and reacts with 2,4-DNP. It's a very important point you have to remember. See here, when it reacts with a carbonyl group, here, see, what is the name of this chemical? 2,4. See, this is hydrazine. One of the hydrogen atom is replaced, and 2,1 addition. So here substitution is there. 2, 3, 4. Therefore, it is 2,4-dinitrophenyl hydrazine. What is the formula for 2,4-dinitrophenyl hydrazine? Its formula is, see, we have that formula. Are you clear? Now, when it reacts with an aldehyde, R C double bond O H, an aldehyde. So when it reacts with an aldehyde. So what will be the product? What will be the product? See again, same thing. Removal of dehydration. Water molecule takes place. Rapid dehydration takes place. Say this water molecule eliminates minus water, and you can easily write the reaction. Say, or say double bond. See here, N again NH, NH. Here H is there. We will get 2,4-DNP. Say NO2, NO2. Are you clear? See, 2,4-dinitrophenyl hydrazone is obtained. Hydrazone is obtained. Only thing is here, carbon to nitrogen double bond. See, when 1 ml of, see how to understood practical, 1 ml of an aldehyde is mixed with 2 ml of, see, suppose 1 ml an aldehyde is taken, 2 ml of 2,4-dinitrophenyl hydrazine have. Okay, just shake properly, just heat, and we will get 2,4-dinitrophenyl hydrazone. See, 2,4-dinitrophenyl hydrazone is obtained. So this is a very important test for an aldehyde. Are you clear? It is an important test for an aldehyde and ketone. A very simple reaction. Practice how to write 2,4-dinitrophenyl hydrazine. You know the formula of hydrazine. What is the formula of hydrazine? NH2, NH2. Are you clear? Then an aldehyde R C double bond O H. On reaction, finally on heating, say we will get 2,4-dinitrophenyl hydrazone. We will get 2,4-dinitrophenyl hydrazone is obtained, and this is a very important reaction, and it is also used to test whether to a carbonyl group 2,4-DNP. a very well-known chemical in organic chemistry, 2,4-DNP. Because, see, 2,4-DNP can answer only to an carbonyl, that is aldehyde and ketone. If you are going to use for an acid or an alcohol, it never reacts. Are you clear? So therefore, it is always we will ask for examination also. Precipitate, regular precipitate is okay. Beautiful precipitate we will get. So you are going to study in laboratory in chemical reactions of aldehydes and ketones. Some of the tests we have to perform. Okay, are you clear? See, dear students, you have to remember 2,4-DNP. Very slowly I am going to deliver you 2,4-dinitrofenyl hydrazone. See, R, C double bond, N, NH, NO2, NO2. Very easy. So, benzene ring is there, therefore you call it as phenyl. It is a substituent. So, these are the substituent. Two nitro groups are there, therefore it is 2,4-dinitro phenyl hydrazine. Are you clear? So, this is important reaction, addition reaction of carbonyl group. Addition of ammonia and its derivatives. Are you clear? Understood? Okay. We shall continue our discussion on aldehyde and ketone reacts with 2,4-dinitrophenyl hydrazine. 2,4-dinitrophenyl hydrazone is obtained. You can perform this test also. Okay. We shall study the other reactions of aldehydes and ketones. Say reduction reaction. An aldehyde, say an aldehyde, or CHO or CHO. So when we do reduction reaction, we shall study the reduction reaction. See in reduction, so this is an aldehyde. See when this aldehyde on reduction with lithium aluminium hydride, So we will get or CH2OH and alcohol is formed. See here OH CH2 we are going to add hydrogen. So if it is a ketone or C double bond O R dash ketone. See on reduction with strong reducing agent like say sodium hydrogen bromide, anything we can use. Say lithium aluminum hydride, a strong reducing agent. Again sodium hydroboron. So in presence of 2H, anyway you can write E1 by H. So again lithium aluminum hydride. Are you clear? Even sodium boron hydride, NaBH4, sodium NaBH4, sodium borohydrate. Anyone we can use. So a strong reducing agent, lithium aluminum hydride. So we will get RCHOH and R dash. So which is a secondary alcoholism. See, ketone on reduction, secondary alcoholism. And here primary alcoholism. So this reaction is studied in the preparation of alcohols. You already studied this in the preparation of alcohols. See R, C double bond O, R dash plus 2H, lithium aluminum hydride, R, CHOH, R dash, which is a secondary alcohol is formed. Are you clear? Okay. So we shall study the oxidation reaction. See, this is nothing but a reduction reaction. Before reduction, remember aldehyde on reduction with strong reducing agent like lithium aluminum hydride, and alcohol is formed. Say what is formed and alcohol is formed. That's all. Okay, we shall continue our discussion on haloform reaction. Very important reaction. Haloform reaction. See, particularly for ketone. Even aldehyde can answer this. Even aldehyde and ketone. Say when R C double bond O, R C double bond O, R dash. So which is a ketone. Okay. See when it reacts with, I'll write like this only. See R dash. See when it reacts with sodium hypochlorite particularly like X, where X is chlorine, are you clear? Chloride, bromide, iodine. See, it is a ketone. When it reacts with sodium hypohalide, a haloform reaction takes place. So we will get C, then O, see here ONA, and one of the alkyl group is skipped out. That is very important. And hypohalide ONA is formed. See, it is on. So this is on acidification. So we will get a final product. Are you clear? So these type of reactions are called haloform reaction. Are you clear? In haloform reaction, one of the methyl group is completely eliminated. It completely eliminates, and here ONA will add, and we will get see X will combine here, and this particular reaction is called haloform reaction. So in haloform reaction, one of the carbon atom is completely reduced. So that is important. I will repeat again. In haloform reaction, see particularly C double bond C, and here we have CH3, here again one CH3, and here again one CH3, and here it may be H. 1, 2, 3, 4, 2, okay, that's all. See, CH3, CH. See when it reacts with sodium hypochlorite NaOCl. See what happens here? Say CH3, again C double bond, and this is H, and this will become CH3. Are you clear? And plus, say this complete one here NaCl. That means ONA, and this complete CH3 elements, and we will get CH3Cl. See, complete methyl group is eliminated. See the reaction. Are you clear? Complete methyl group is eliminated. That is the main concept of haloform reaction. In a haloform reaction, one of the carbon atom get completely reduced. If suppose it contains 5 carbon atom, 1 carbon atom less is the product. That point you have to remember. Are you clear? Understood? So this particular reaction is called haloform reaction. Then we shall continue our study on oxidation rate. Oxidation rate. See, oxidation rate. Oxidation reaction. So when an aldehyde is oxidized in presence of strong oxidizing agent like acidified potassium dichromate K2Cr2O7. So it is oxidized to carboxylic acid or COOH. Carboxylic acid is obtained. Are you clear? When an aldehyde on oxidation in presence of strong oxidizing agent like acidified potassium dichromate K2Cr2O7 or potassium permanganate KMnO4, even with nitric acid or even with all, say KMnO4 or with nitric acid HNO3 nitric acid. So these are oxidizing agents. These you have to remember. See, sometimes we will write the reactant side and even product side. So oxidizing agent you have to remember. This reaction takes place either by potassium dichromate or by potassium permanganate or by nitric acid. So these are strong oxidizing agents. Are you clear? A very simple reaction, dear students, which you can easily remember. See, aldehyde on oxidizing with strong oxidizing agent like potassium dichromate or potassium permanganate or by nitric acid. Aldehyde is oxidized to carboxylic acid. So study this reaction. Aldehyde is oxidized to carboxylic acid. Are you clear? Okay. Next. Say, particularly by mild oxidizing agent, a weak oxidizing agent, mild oxidizing agent. So, reaction of aldehydes with mild oxidizing agent, mild oxidizing agent. See, reaction of aldehydes with mild oxidizing agent. See, when an aldehyde or CHO, so when it is oxidized in presence of, see, ammonium silver nitrate Ag NH3 twice, AgNH3 again twice, plus, see, this is nothing but in basic meaning 3 OH minus, and we will get, see, this ammonium silver nitrate, we call this as ammonium silver nitrate. So this is an aldehyde. So it is oxidized. It is oxidized. I am going to write here. It is oxidized to. See, a carboxylate ion. And it gives a bright silver mirror 2Ag plus 2H2O plus 4NH3 ammonia is formed. And this is nothing but a mirror. Are you clear? And this test is this particular which is answered by aldehyde only. So this test is used to differentiate between aldehyde and ketone. Ketones does not answer this. See, aldehyde on heating with ammoniacal silver nitrate solution, and this particular reagent is called Tollens reagent. Tollens reagent. It is called Tollens reagent. Are you clear? See, when an aldehyde is oxidized, the reaction is oxidation or heating with ammoniacal silver nitrate in the presence of basic medium. In the presence of basic medium. In the presence of basic medium, a bright silver mirror is obtained. Say, in a test tube, we have to take 1 ml of an aldehyde, add 1 ml of or 2 to 3 drops of ammonium hydroxide, then add silver nitrate solution to that, and that mixture is called Tollens reagent. And just heat it on slowly heating along the sides of the test tube, we will get a beautiful mirror image. A mirror we can find, not mirror image, mirror. And that is nothing but the liberation of silver. And it is an oxidation reaction. An aldehyde gets converted into a carboxylate ion. See, the entire reaction, and this particular reaction is used to test or used to differentiate between the aldehyde and the ketone. Ketone does not answer this reaction. Ketones does not answer this reaction. Are you clear? Understood? Ketone does not answer this reaction. See, when an aldehyde reacts with ammoniacal silver nitrate solution in presence of a basic medium, a bright silver mirror is obtained. Are you clear? So this reaction is test for an aldehyde. It is the test for aldehyde, and this reaction is called, and this particular chemical is called Tollens reagent. Are you clear? It's called what? Tollens reagent. Are you clear? Okay, we shall continue our study on aldehyde. A Fehling solution test. So this is nothing but a Tollens reagent test, and we shall study Fehling solution test. See, Fehling solution. Say it consists Fehling A and Fehling B. What do you mean by Fehling solution? So aqueous copper sulfate is called Fehling A, and Fehling B sodium, potassium, tartarate, and this mixture is called Fehling B. See, when this is mixed and an aldehyde along with Fehling solution, to C2 plus, which is in aqueous, plus again in basic medium 5OH minus, and we will get a reddish brown color precipitate. Again, it is aldehyde is oxidized to RCO minus and carboxylate ion, and this is Cu2O, which is a reddish brown precipitate. Are you clear? And again plus 4H2O. See, are you clear? 3H2O. Oxygen is used here, another non-oxygen is used here. So this is nothing but a red precipitate. Are you clear? See here, aldehyde is oxidized to carboxylate, and aqueous copper sulfate, a copper oxide, a precipitate is formed. So this reaction is answered only by an aldehyde. So this is the major reaction which is used to differentiate between aldehyde and ketone. Aldehyde and ketone. Are you clear? Say Tollens reagent and Fehling solution. Sodium, potassium, carbonate. Aldehyde gets converted into a carboxylic. Okay? Are you clear? So we shall continue our discussion on tomorrow. Dear students, we completed the Tollens reagent as well as Fehling solution. What is Tollens reagent? Ammoniacal silver nitrate solution is called Tollens reagent. What is Fehling solution? Fehling solution consists two parts. One is Fehling A, another is Fehling B. Fehling A is an aqueous copper sulfate solution, and Fehling B is sodium potassium tartrate. That mixture is used as an oxidizing agent when aldehyde is oxidized to carboxylate ion, and a reddish brown precipitate will be. So this is the special two important test for aldehyde. Are you clear? Okay, I'll stop here. Thank you.